Hello, pre-calculus students. Hope you had a good weekend. This week we only have one lesson, 3.10, solving logarithmic equations with properties. Then you'll have a practice test and a test. So that's what is on the agenda for this week. Now, we've already solved logarithmic equations. We've done that several times now. We've used the one-to-one property, and we've dropped the base on both sides to do that. We've had some problems with extraneous solutions. That caused some confusion for a few people that have contacted me, but hopefully you're able to work through that. So this is very repetitious of what we did, with the exception of the fact that we will be using the product and quotient properties to condense the equation before solving it. So if you went over the property lesson last week, and I see that E doesn't look like an E, I got to fix that. Okay, so anyway, if you did the lessons from last week, you learned the properties, you should be good to go. If not, if you're not caught up on last week, you need to get that before you do this. All right, and then we've really covered everything. This is just putting together topics we've already learned. So the directions are simple. Solve each equation. I'm just going to go through and use examples. I'll do the evens like always. I'll ask you to do the odds, and that should be about all it takes. So here we go. Number 2. You might be tempted to do this, to cancel out the logarithms. You get 4x plus 9 equals 73. Unfortunately, it doesn't work. I will do it and show you that it's wrong if you really care. 4x equals, what is that, 64, divide by 4, x equals 16. We go down and check the answer, and it will be wrong. I hope you're watching this with the sound turned on and you hear me say that it's wrong. That is not the right answer. I mean, that was the right answer. This is not the right answer. So, the idea of crossing out the logarithms, the one-to-one property, only works if you have a logarithm on one side and one logarithm on the other side, that you're allowed to cross those out. That's it. It's called the one-to-one property because you have one logarithm here, one logarithm there, not two logarithms and one logarithm. So what you do is you use the quotient property. Oh, well, in this case, the product property. Let me jot those down just in case you've forgotten. In fact, I'm going to make some room right here and jot those down. So the product property is basically this. If you have log of x plus log of y, that becomes log of x times y. And then the quotient property is this one. If you have log of x minus log of y, it becomes condensed into one logarithm, but it's x divided by y. You remember a third property called the power property? Since it doesn't really come up on this worksheet, I'm not going to review it, and I'm not going to throw it in your face right now. So we just won't worry about that. Okay, so because there's a plus here, I can use the product property. I can condense this side into one logarithm, and then it becomes 4x times 9 equals log of 73. Now, what is 4x times 9? Well, 4x times 9 is 36x. And now, since we have one log on each side, we can use the one-to-one property to cross those out. 36x equals 73. Divide both sides by 36. 73 is not divisible by 36, and it won't even simplify or reduce either, so that should just be the answer. Let's check number 2. Scroll down 1.5 miles, and there it is. This isn't a terrifically long worksheet. I just spaced it out into multiple pages so you have plenty of room to show your work. Okay, number 4 is also a plus sign here, so I'm going to condense it in the same way. This happens to be a base 8 logarithm, so that's going to be 5 times 5x equals 2, and of course 5 times 5x, you can make that 25x. Now here, we do not have a logarithm on both sides to cross out, so this is not a one-to-one property. For this one, we're going to cancel out the logarithm by dropping a base. Remember, bases and logs cancel each other out. But if you drop a base on one side, you have to drop the same base on the other side. So I end up with 25x equals 8 to the second power, which is 64. Now divide both sides by 25. And 64 is not divisible by 25, and it won't reduce or simplify, so just the fraction 64/25 should be the answer to number 4. And there it is. So that's the general idea behind this. Now, both of these problems were product properties. You see with a minus sign, there's a quotient property, and then another quotient property. But we get into more advanced, more complicated, see x squared and another x squared, and then eventually we get somewhere with, natural logs, if that's complicated, maybe not. X quotient property with another x, so we're going to have a fraction with a variable in the numerator and the denominator. So these will get fairly more complicated as we go. You might want to skip ahead if you feel like you get it. I would not just start the homework yet, though, because, I don't know, or maybe if you do start the homework, if you get stuck on a problem, come back and rewatch parts of the video. Of course, you can always drop me an email or a comment if you have questions. All right, anyway, let's continue. So, number 6, log base 5 of 2 minus log base 5 of x plus 6 equals 2. I can condense these two logarithms using the quotient property. Log base 5 of 2 over x plus 6 equals 2. To cancel out that logarithm, I need to drop a base 5, and do that over here, which cancels those out. 2 over x plus 6 equals 5 squared. 5 squared is 25. Now, how do you solve this? Generally speaking, there's a few different ways to explain this. One way to explain it is you put a 1 under here. You know, any whole number you can make a fraction by putting it over 1. And then cross multiply. You probably learned cross multiply way back in middle school. 2 times 1 is 2. And then 25 times x plus, oops, I just about made a mistake there. 25 times x plus 6. You can distribute and work it out from here. So 2 equals 25x plus, what's 6 times 25? 150. Now subtract 150. 2 minus 150 is negative 148 equals 25x. Divide the 25 to isolate x. And I think you're done. I don't think this will simplify. Negative 148 over 25 should be the answer to number 6. And there it is. So this, when you get a fraction kind of like that, a quotient method, this idea of cross multiplying can become very important. Looks like it's going to happen again right here. Oh, by the way, I guess what you're supposed to then do is plug this back in to make sure you don't have any extraneous solutions. Those only really happen when you have a negative inside the logarithm, and I realize that's a negative number right there, but it's less than 6, so when you add it to 6, you still get a positive. That's why there's no extraneous solution. So I'm not going to worry about that on this one. But I think there's some of those coming up if I remember right. So anyway, all right, I'm going to condense this. The minus sign tells me that this is going to be a quotient property. X plus 1 on top. The first one goes on top, the second one on bottom. Okay, now here we can use the 1-to-1 property. We do have the same log on both sides, so we cancel those out. X plus 1 over x equals 41 over 1. Cross multiply. 1 times x plus 1, which is simple. X times 41, 41x. Obviously, distributing a 1 doesn't really do anything. From here, I'm going to subtract x on both sides to get my like terms together. 41 minus 1 is 40. Divide both sides by 40. X equals 1/40. Now, if I plug in 1/40 here or here, will that give me an extraneous solution? No. It's a positive. You plug it in. You have positives. It's good. And there it is. Okay, it turned into a triangle. My check mark turned into a triangle magically, and that caused my Notability to crash. So let me restart it, and we can continue. There, 1/40. Glitches are funny. All right, number 10. Now this is back to a plus sign, so when we condense this, we're going to use the product property. 3 times 3x squared equals 2. So log base 9 of 3 times 3, 9x squared equals 2. To cancel out this logarithm, I have to drop a base. So drop a 9 on both sides. You get 9x squared equals, 9 squared is 81. Divide both sides by 9. X squared equals 81 divided by 9 is 9. To solve this, we're going to use something in algebra called the square root method. You square root both sides. And intuitively, you would say, oh, the square root of 9 is 3. That's my answer. When you use the square root method, you actually have to put a plus minus on your answer because negative 3 times negative 3 is also positive 9. That means the positive 3 or the negative 3 could be an answer. Now, we do get suspicious of negative numbers with logarithms, but if you check it, if you come up here and plug in a negative 3, negative 3 squared is positive 9. 9 times 3 is 27. This is going to work out just fine. So both the positive 3 and the negative 3 should be correct answers. Let me scroll down and check. And there it is, positive 3 and negative 3. Yeah, okay, let's look at number 12. Here we have minus, so I need to condense this logarithm, log base 8, using the quotient method. X squared minus 4 on top, 3 on bottom, equals 2. To cancel out the logarithm, I need to drop a base 8 on both sides. I get x squared minus 4 over 3 equals, what is that, 64. Put this over 1 and cross multiply. Well, 1 times x squared minus 4 is going to be x squared minus 4. I mean, yes, I could do this, but as we saw in a previous problem, multiplying by 1, just a waste of time. 3 times 64. 3 times 4 is 12. Carry the 1. 18, that's 192. Add 4 to both sides. X squared equals 196. Square root both sides. Again, whenever you square root, you have to put a plus minus on your answer. What is the square root of 196? I believe it's 14. I kind of have my my squares and square roots memorized, but I also kind of screw things up, so I'm just going to check. Square root of 196, yeah, 14. So plus minus 14. Can I have a negative answer here? Yeah, because when you plug in negative 14, it gets squared. When you square negative, it turns positive. It should work out just fine. So number 12, plus minus 14, there it is. All right, do I need to keep the calculator handy? I think all the rest of the numbers are small enough I can do them without. We'll see. Number 14, very similar. Minus means we make this into a quotient property. Log. By the way, quick review. If there's no base on a logarithm, what base is it? If you said base 10, you are correct. What's that called? If you said the common logarithm, you are correct. Anyway, so log of x squared plus 8 over 2 equals log of 4. We do have a logarithm on both sides, so we can use the one-to-one property here. X squared plus 8 over 2 equals 4 over 1. Cross multiply, x squared plus 2, nope, x squared plus 8 equals 2 times 4, which is 8. Subtract 8 on both sides, x squared equals 0. Square root both sides. Technically, yes, whenever you square root, you're supposed to put a plus minus on your answer, but 0 is a special number. It's not positive or negative, so the answer should just be 0. Or you could say it's both positive and negative. I don't know, there's different ways of interpreting 0. But the point is, 0 is the answer. There's not multiple answers here. I'm just going to peek ahead at number 16. Look at that. Doesn't that look wonderful? All right, let's do 16. So, plus sign means that when I condense this, I need to use the product property. 10 times x squared plus 3 equals 2. And I'm going to go ahead and simplify that. Log base 6 of 10x squared plus 30 equals 2. To cancel out the logarithm, I need to drop a base 6 on both sides. I get 10x squared plus 30 equals 36. Yes? Yes. Now, let's see. Subtract 30 on both sides. 10x squared equals 6. Okay, I can cope with that. Divide both sides by 10. X squared equals 6/10, and then you know that becomes 3/5. Square root both sides. Let me come up here. X equals, whenever you square root, you have to put a plus minus on the answer. Square root of 3/5. Now that becomes square root of 3 over square root of 5. You can't square root 3, you can't square root 5. 3/5 does not reduce. So you look at that and you say, okay, there's my answer. Well, if you remember from a second ago, on that problem, that was not the answer. So what's up with that? Okay, so we're going to dive back into Algebra 2 for a little bit. At some point in Algebra 2, you should have been taught that you're never allowed to have the square root on the bottom of a fraction. I know I taught it to my Algebra 2 students last year. That being said, I do not remember any of my Algebra 2 students actually enjoying the process that I'm about to talk about, and I bet a lot of you blocked it out of your minds. So let's review. If you ever have a square root on the bottom of a fraction, you need to do something called rationalizing the denominator. So whatever that square root is, in this case square root of 5, you multiply that on top and bottom. And what do you get? Well, on top, square root of 3 times square root of 5 becomes square root of 15. On bottom, square root of 5 times square root of 5 becomes square root of 25. Now you might look at that and say, well, big deal, I still have a square root on the bottom. In Haskell, you said you're not allowed to have a square root on the bottom. Well, yeah, but square root of 25 is special. You can actually do it. What is the square root of 25? Square root of 25 is 5. So since you can simplify that, the square root disappears, and now we have an answer with no square root on the bottom. So number 16, we ended up with a square root in the denominator. You have to do this little rationalizing step to make it work, to make it a final answer. So go back and check just to make double sure, and there it is. Okay, let's talk about 18. All right, we have two logarithms separated with a minus sign, so we're going to have to condense them using the quotient rule. So put a fraction bar, x plus 5 on top, 5 on bottom, 5 on the other side. Boy, there's lots of 5s in this problem. Now, if we had ln on both sides, I'd cross it out because ln is just a logarithm, but I can't do that, so I have to drop a base. What is the base of ln? All right, either you said the right answer or not. The right answer is e. You have to drop an e on both sides to cancel that out. X plus 5 over 5 equals. So now what's e to the 5th? You have two options here. Grab a calculator, type in e to the 5th. You will get a decimal. It's the type of decimal that goes on forever, like pi. Then you have to round it off and keep working it out. So that's one option. The other option is just to leave it e to the 5th. E, even though it's a variable, just treat it, even though e is a number, you treat it like a variable and then continue your work. So how do I continue this work? Well, next, multiply both sides by 5 to cancel that out. X plus 5 equals 5e to the 5th. Subtract 5 on both sides. X equals 5e to the 5th minus 5. And that is the solution to number 18 right there. It would have been nice if all the numbers weren't 5. If you look at number 19, the one that you do, at least there's a couple different numbers there to work with. But it's very, very similar. When you do 19, look back at 18 for help if you need to. Number 20. Plus tells me that when I condense this one, I need to make it a multiply problem. So that's x minus 7 times 2. I can go ahead and distribute that. ln of 2x minus 14 equals 5. Cancel out ln by dropping a base e. 2x minus 14 equals e to the 5th. From here, you're doing algebra. Add 14 to both sides. 2x equals e to the 5th plus 14. Divide by 2. X is isolated, and this is your answer. Or you could split it into e to the 5th over 2 plus 14 over 2, which is 7. Either one of those would be right answers. Or you could take e to the fifth over 2 and make it 1/2 e to the fifth plus 7. So here we have 3 different versions of the same answer. I wonder which one the answer key chose. Number 20, the first one. So right there, I didn't even need to show you any of this stuff. Oh well. Excuse me for giving you an education. No, just kidding. Okay, number 22. Minus. So I need to condense this using the quotient property. X minus 4 over x equals 3. Now what? Cancel out ln by dropping an e on both sides. X minus 4 over x equals e to the third. Put this over 1 and cross multiply. This way, 1 times x minus 4 is still x minus 4. X times e to the third is e to the third x. Now what? How do I solve this? Okay, we're trying to isolate x, so I'm going to get x on both sides together. From both sides, I'm going to get them together. So subtract x on both sides, you get negative 4 equals e to the third x minus x. Now this expression, each term in that expression has x as a common factor. I'm going to factor out x. It gives me e to the third minus 1. To isolate x now, I can divide the whole thing by the quantity e to the third minus 1. So I get x equals negative 4 over e to the third minus 1. That was pretty complicated. Let me check number 22 and see if they don't have some wacky. No solution. What? Say what? Oh, great googly moogly. What is negative 4 over e to the third minus 1? Well, I know I told you not to grab a calculator and to leave, leave e like it's a variable, but you have to remember that e is not a variable. E is a number. And numbers can be either positive or negative. So watch this. If I do negative 4 over, e raised to the third power minus 1, I get a negative, let's say, 0.2. Negative 0.2. Well, if you plug a negative 0.2 in right here, you're doing the logarithm of a negative number, and that doesn't work, right? ln of negative 0.2, undefined. You cannot log negative numbers. So even though I went through all this work and I got this solution, there is no solution because you're not allowed to log a negative number. Ugh. That was intense. All right, number 24. Again, condense your logarithms. With the plus sign there, I can make it times. That's going to be x plus 6 times x equals 3. If I distribute that, I get log base 3. What happened to that g? Oh my gosh. Log base 3 of x squared plus 6x equals 3. Now cancel out the logarithm. How? Drop a base 3 because it's a base 3. And then do the same thing here. X squared plus 6x equals 3 to the third power. 3 raised to the third is 27. Now we've got a quadratic. I'm going to work it so that one side is 0, so I have to subtract the 27. And you can solve a quadratic a number of different ways. I'm going to use factoring. 9 times 3 is 27. Positive 9 minus 3 adds up to positive 6. Now set each of these factors equal to 0. And when you solve this one, you get x equals negative 9. And when you solve this one, you get x equals positive 3. Why did I write a plus sign? I don't know. Now let's go back and check. Can I plug a negative 9 in here or here? No. Either way, it gives me the log of a negative number, which is undefined, right? Function log base 3 of negative 9, undefined. So that is an extraneous solution. Can I plug in a positive 3 to the original equation up here? Yeah, no problem. Make this a positive 3, make that a positive 3. It's all good. So for number 24, positive 3 should be the only solution. Oh, and look at number 23. Okay, clearly there is work to be done here. I do expect you to show your work. You cannot just get away with writing answers down. I've thrown back a number of assignments to people who've turned them in with no work. So I just give you 0. You can still redo it if you want, but definitely show your work. If you have any questions, definitely contact me. I'll do my best to help you. This is the only assignment this week, but you do have to prepare yourself for the practice test and then the actual test. All right, so I guess I'm going to stop there. Good luck, and I hope you have a good rest.